Hey guys, welcome back. So, I want to go ahead and just wrap up chapter 16. I know it may seem fast since we only had 1 week on this, but that's actually because chapter 16 only covers geometric distributions, binomial distributions, and then there's a little section at the end that talks about converting binomial distributions into the normal curve. But in reality, the AP test doesn't really cover the whole like binomial into normal curve thing. So we're going to skip it because I just want to make sure I get you guys all the content as quickly as possible, and I don't want to overwhelm you with things you don't really need. So we're going to skip that part and just call it a day on chapter 16. So before we just completely call it quits, I do want to do a quick review of the two side by side, just so we can kind of talk about what's the same thing, what's the differences between a geometric distribution probability question and a binomial distribution probability question. Okay. So the first thing is, what actually defines a geometric versus a binomial probability? So if we're looking at just a straight up definition of the two, a geometric distribution is when we have a set Bernoulli's trial, which means we only have two options, success or fail, and we're going to do those trials over and over and over until the first success occurs. All right. Now, the probability question could be something along the lines of, hey, what's the probability that the first time you do blank success will be the fifth attempt or the third attempt or somewhere in the first three or like the fifth attempt or higher or things like that. Whereas binomial, we don't do this whole until the first success thing. For binomial, we actually have a set number of trials. So before we even get started doing it, we say, hey, we're going to do it 10 times. And then your question has to do with how many successes out of the 10 you would have. So it would be questions where it's like, hey, what's the probability you would make 7 baskets out of the 15 you took? Or what's the probability that you would flip over a heart 9 times out of the 25 attempts that you're going to do? Those are binomial questions where it gives you how many successes at once, but it also gives you the total number of attempts that you're going to be making. Whereas geometric was just you just want to do it over and over until you get that first success. All right. Second thing for us to look at, what are the key variables? What are the key players in this question? So for geometric, we only have the probability of success and the probability of failure. All right. So P is our probability of success, Q is our probability of failure. It's usually very easily defined in the question. I know some of your guys' work had it be a little bit more difficult where it made you like do a multiplication rule to find the probability of success or something like that. Binomial is actually almost the same. It still has the P and Q, but the only new one is it also has an N for your set number of trials, which should be self-explanatory since geometric, you just keep going until your first success. In binomial, you go until you hit the set number of trials. The next thing we covered with these questions were the expected value and standard deviation. We actually didn't even have the standard deviation formula in the notes for geometric because it is extremely rare that you ever talk about the standard deviation for geometric. But the expected value is a very important part of those questions. The expected value is, all right, we know that the question itself is we're going to do this over and over and over again until we hit our first success. All right. Um, how many times should I have to expect to do it before I hit that first success? That's what your expected value is. Your expected value tells you how many times you would expect to have to do it until you get that first success. On average, it's not going to be every time, it's just going to be on average. So the formula for that is actually just 1 divided by P, and don't forget, P is just your probability of success. All right. Standard deviation for that is the square root of Q divided by P squared. But again, we'll rarely see that. What would that mean in context? It means that, hey, we would expect it to take this many attempts, give or take a few. All right. Whereas with binomial, we have those same two things, our expected value and our standard deviation. And because we're not doing a number of attempts until we're done, and instead a set number of attempts, the expected value is a little bit different for binomial. All right. Expected value for binomial is, all right, we're doing it 15 times. How many of those do you expect to be a success? All right. So that's where your expected value is there. And the way that we find that is just n times p, where again, n's your set number of trials, and p is the probability of success. Remember, for both geometric and binomial here, we're always going to use the decimal form of your probability of success or failure. So if let's say there's a 52% chance of success, then your p-value would be 0.52. All right, the standard deviation for binomial, keeping suit with the rest, it's going to be square root of n times p times q. And again, you're just plugging in your set number of trials, your probability of success, your probability of failure. Multiply them together, take the square root. And standard deviation in this case would be, okay, if we expect to make 10 of the 15, your standard deviation would be, on average, how far above or below 10 successes would we expect to have, right? Down here at the bottom, I have your calculator functions that we covered for each. Now notice it does say menu 55 geometric PDF/CDF, and same with the binomial PDF or CDF. And that's just because, remember, we use a PDF in your calculator when you're dealing with one number. So for geometric, that's going to look like, I don't know, what's the probability that the first time you pass a test in Caproni's class would be the third test you take? Well, then in that case, x is 3. Because it's just one number, you would use PDF. Whereas if I said, hey, what's the probability that the first test you passed would be one of the first 5 tests that we take in the class? Then your probability question is actually asking you anywhere from 1 to 5, so you would use CDF with a lower bound of 1, upper bound of 5. Whereas with binomial, same thing. PDF is when x is one number, CDF is when it's multiple. But because we're in a different situation here, PDF would be, hey, what I'm going to, I don't know, shoot this arrow at a target 20 times. What's the probability that I'm going to hit the bullseye exactly 3 of the 20 times? That would be a PDF question where your x would be 3. A CDF question would look more along the lines of, what's the probability I'm going to hit that bullseye, I don't know, 5 times or more? So then your probability would be 5 all the way up to your max number of trials, which I think is what, 20, so 5 to 20. And you would go ahead and plug that in for your lower and upper bound. Now, for geometric, anytime it says like 10 or more, you go up to 9999 as your upper bound. For binomial, you can still go up to 9999 when it's an infinity question, but in reality, the highest number of successes you can have would be n, because that's your number of trials. So, like, I can't take 40 tests and get 45 passing, because you can't pass 45 tests if you only took 40. So in reality, the highest you ever have to go for a binomial is the n, because you can't have more successes than you do trials. All right. So this is just kind of a in general breakdown of the two side by side, geometric, binomial. I'll give you guys a few more practice questions to go along with this, so look for that post right underneath this one. But after we do a few more practices with this, we're actually just going to call it a day for geometric and binomial, and we will move right along into chapter 17. So, everybody, thanks for joining me again. You will hear from me shortly, I am sure. But as always, stay fit, stay healthy, and have a wonderful day.